Elementary statistics, taking a look at section 9.5, two variances or two standard deviations. So now we're going to look at comparing population variances or population standard deviations between basically how a population could vary or range within our data that we have. Now, this test that we're going to use, there's more than one style to go about, but our most common style that we're going to use is called the F test. Okay, so the F test for testing claims made about two population variances. Once again, this was done by Sir Ronald Fisher, who developed this test. The F test requires that both populations have normal distribution. This test is very sensitive to departures from normal distribution, so normality requirement is quite strict. So we got to make sure that we have normal curves as we talk about it. Now, the actual F test itself could be two-tailed, left-tailed, or right-tailed, but we make computations much easier by stipulating that the larger of the two variances is denoted by S or S squared sub 1. Okay, so our variance 1. So what this means, okay, so if we kind of look down here, our first set of data has to be the data that has the larger of the two variances. And then the second set of data is the smaller of the two variances or standard deviations. Okay, the larger of the two standard deviations would give us the larger of the two variances also. So do realize that we have to first figure out which one has the larger variance, and then we let that be our first set. So it's not like in the past where, oh, this one could be first or this one could be first. No, we have to make sure that we have our larger one first. It just makes the overall test itself easier with values and with working through it. So once again, requirements, they must be independent to random samples and a strict normal distribution. Okay, so we can't be saying, oh, if we have so many, we don't have to worry about normal distribution. No, no, no. It is not robust against departures from normality. We have to make sure that we have a normal distribution. And then, like everything, you know, they tell us how to calculate the F test by taking the first standard deviation divided by the second standard deviation. There's a table in the back of the book, A5. Let's see here, it's page 738, 739. Once again, it only talks about the two types of alphas in here. Once again, our significance levels of 0.025 or 0.05, once again, the two-tailed portion of it. Do realize that then we have our degrees of freedom. We have different ways of working through this problem. Okay, so I'm going to come down here and point you in our direction we're going to go with this right away. We're using our calculator. Okay, so once again, it's a two-sample F test is what we'll be using on here. So we have two different populations we're comparing the variances between or standard deviations between, and we're going to be looking at how are they comparing to each other for that variance. Once again, the data or stats depends upon if we have the already statistics given to us or if we just have the lists of information, then we'll be typing them in and bringing them over. And then once again, we'll be calculating out our null hypothesis as being equal to, so the standard deviations equal each other, and then does it not equal each other? Is one less than? Is one greater than? Basically, on some tests, we think back to the mean. There are some values in there that we had talked about back a couple sections ago where we talked about one standard deviation equals the next standard deviation. Well, how do we do that? Well, a lot of times they might have ran this test first, so then they could come back and say that this is overall working. Overall, we have to remember F distribution follows a standard variance curve, which is a right tail, so it is not symmetric. Okay. Also, the F distribution cannot be negative. Okay, so whatever happening here, we can have negative values, and their exact shape of the distribution depends upon the two different degrees of freedom. Okay, so once again, there's 2 degrees of freedom in here. Coming back, we have a numerator degrees of freedom, denominator degrees of freedom. Once again, determine number of columns in table A5. So there's a whole bunch of things going back and into this. So that's our main test. Now, there are alternative methods, okay? We are not going to go through the procedures for these alternative methods. We do not have the programming for it. We do not have all the accessibility for these other ones. Plus, sometimes, once again, doing by hand, the computation time takes tremendously more for some of these other procedures. Some of them might be more precise than our F-test at times. Sometimes they won't be. It all depends upon there, and that's the wonderful world of statistics for us, is that nothing's ever perfect, but we can only be close to what is actually happening. So, considering what's going on here, they talk about the count 5. Okay, so the count 5 method is a relative simple alternative to the F-test, and it does not require normal distribution populations. Okay, so if we didn't have normal distribution, but we still want to do something, that's where this count 5 method comes in. If the two sample sizes are equal, and if one sample size has at least 5 of the largest mean absolute deviations, then we conclude that its population has a larger variance. Okay, so basically the mean absolute deviation is the distance from the mean to that outside. Does it have the 5 largest individual ones in there? Then we say, well, overall it's going to be there. Does require you to calculate out a bunch of other information, but it's basic information that could be done by hand versus needing a calculator. Then there's the Levine-Brown-Voorhees test. In this test, it's another alternative to the F-test. It's much more robust against departures from normality. Within the first sample, replaces each x with the absolute value of x minus the median, and then do the same for the second sample. Using transformation, conduct a t-test for equality of means for independent samples. Because the transformation values are now deviations, the t-test for equality of means is actually a test comparing variations of two samples. So basically they start and they take it back to a t-test. So rather than computing this whole other separate test, this whole test that's over here, that f-test that we're going to be using, they're going to do all this work towards it and change the data, and then they conduct it towards that t-test that we did in the past. Is it better? I could not tell you. I wouldn't say that one is better than another. Sometimes if you have more information or better information where you know you have that normal curve and everything else, then you can definitely tie in that yes, this test would be better. If you get away from those normal curves, well then is the test really itself going there? And a lot of that comes into the data that we start working with. So do realize we aren't going to be using these other methods. We're going to be using our F-test, and we'll be showing you how to basically go through the calculator and get our values and then state our answers. So just like in the past, the calculator is doing the work for us.